So let's get into this quickly. Achieving operational resilience through DevSecOps. What does that mean? So in the blurb, I mentioned the fact that I was a firefighter, but before we get into it, just a couple of pieces of information about the company that I work for. We're using about 30% of the global 100 companies. So we're in a lot of very big organizations. Not many people know about us. We got acquired by a company called Perforce earlier last year in February last year. So we're now part of the platform automation group and include products like Puppet, BlazeMeter and things like that, testing tools. And Perforce provides software tooling from coding to what they call business ready. So a little bit about my firefighting credentials, right? So I tried to equate situations that go out of control. So I was a firefighter, and this is one of my young recruits, probably could even be about 20 years ago now, because obviously firefighting is a really easy job. It's actually child's play, okay? But yeah, I was a firefighter for 10 years, from 2001 to 2011, and the only reason I left was because I moved countries, so I was a retained firefighter, and at this point I was a crew manager here, and we were teaching children. So that's my firefighting credentials, and the main thing I learned, I think, the two main things was, if you haven't practiced things, then things can go rapidly out of control. So if you haven't drilled and learned things can go rapidly out of control. And that's kind of true with databases as well. I was doing a fire behavior training exercise, which is a 2-day exercise where you're going a burning building and it's all very difficult. And the night before I was doing my final test on that, my database that I was running for a company called Orange crashed, and I had to recover the database for about 4 hours overnight. So I wasn't very fit for the fire behavior training the next day. So that's sort of how you equate firefighting. Things can go rapidly out of control, and if you want to be able to do anything, you need to make it simple, right? The other thing that I learned was, you think about a fire in a building, it's a big orange thing, you just jump over it and run out of the building. But the reality is that everything goes crazy, right? It's the smoke, it's the dark, it's the disorientation, it's the terror, and that's what slows you down. I've also deleted tables in a production database and had the same kind of feeling that your mouth goes dry, and you need to call the man that knows what to do. Okay, so that's a little bit of background. So now what I want to do is I'm going to teach you a little bit of a block sharing exercise. Does anyone know what block sharing is? Hands up. Right, okay, so the product that I'm using, and ZFS file system, uses block sharing, right? And what block sharing does, I'm going to describe it here, right? So here's your production database. All the blue squares are blocks that are filled in. They're written blocks. We've got this tool here, which is our continuous data engine. And then we've got 4 database servers where I'm going to put databases, okay? And so what I do here, I do an ingest of our database, an RMAN backup. So I get a full copy of the database into Delphix. And what I do there, I've compressed that down. So now I've compressed all the blocks into a small space. And the next thing I want to do is I'm going to provision that database for one of these servers. Now normally, if this is a 10 terabyte database, I've got it compressed down to 3 terabytes. So if I want to run a database on that server, then I've got to move 3 terabytes across there, and that's going to take me, generally it's an hour a terabyte, that's 3 hours to move that database across there. You can get it moved a lot quicker with some storage, but in this case, instead of moving the data, what I'm going to do, I'm going to create a set of new file pointers to those shared blocks, and I'm going to mount an NFS mount point there, and I'm just going to point to the blocks of data. So now I've got a full read-writable database, and I've done it in just a couple of minutes. And I've barely moved any blocks at all. I've just added some storage for a set of blocks here, which is megabytes, okay? And I can do that across, and I can create 4 copies of the same database, read-writable, running on those target servers. So you're probably thinking here, yeah, but what about if on the database server 1, what if I change a column or write a row? What happens then? Well, I create a new block in this system here and a new private file pointer to those blocks. So I've got a complete database there. It's going to grow over time, but it's completely independent, but I'm still sharing the blue blocks, and that can happen across all of these databases, right? They're doing updates, they're adding data, but if you see here, I've got 1 terabyte here, and I've got 10 here and just over 3 there, but it's minuscule amount of additional data. So what happens now, as this database moves over time, we're going to create new blocks, we're going to update blocks, things are going to change. So how do I get that data into Delphix? Well, I'm going to run an incremental backup, so I'm going to get all of those blocks across there. But as you can see, I've got the new blocks, the changed blocks, and I've removed a few of the old blocks. I've expired those blocks that aren't being used in the target servers over there. And then if I want to, I can actually refresh this database from the latest copy, and when I do that, I actually release some storage. So I can refresh that and the blocks can be freed, and I can refresh the other one, and I can refresh that, and I can keep that one running, right? And that's going to grow slightly over time, but I'm still got a very small amount of storage going on here. So that's block sharing, right? So that's how I can give you multiple copies of a multi-terabyte database without using much storage. The one factor that you need is that between this engine and those target servers, you need quite a big network, okay, because all of the traffic's going through there. So how we handle that and the I/O coming into here, because it's got to hop from there to here to get the I/O, is we put a massive cache. It's called an ARC cache in ZFS terms, but the performance of those virtual databases is very impressive. And we've got a number of customers that say that it's on a par. Some transactions are quicker, some are slower, some are about the same. So the performance is still very good with this idea of virtual databases. So what does that mean in a kind of a production environment? So this is an example it's actually a customer example. It was a retail customer, and they had 6 non-production copies it was almost 20 terabytes. I made it 20 terabytes so I could do the maths. It was 17.6 terabytes or something. But anyway, in a traditional environment, you've got a backup server, so you can recover production if you want to, but they use that backup server to restore those databases. And they said it was a 24 to 36 hour process, but they said, well, it's sometime a bit longer than that, because there were a lot of errors in that process, because they didn't refresh these databases very often, and when they did, it was manual and they broke things. So this usually took about a week when the DBA had time to do it, okay? So these are the non-production environments. So what I said is, well, if you put Delphix, this file server in place, so our system is a virtual machine, right? So you import it into a hypervisor, and then we automatically run an RMAN backup. So we put a file on here, dynamically create an RMAN backup. The full backup into Delphix is going to take a number of hours, an hour a terabyte, 20 hours. We've got the data inside of Delphix. Now we can do that provisioning, the block sharing that I talked about, and now we've shrunk that down, and I've said less than an hour, okay? But actually, it take about 10 minutes. In this case, this customer, when they implemented it, they didn't have a thing called block change tracking on, so it did take 20 minutes, but normally we'd expect it to take less than that time, a few minutes, to create a copy of the database. These guys didn't have any additional storage, so we stole the storage off of that database server, gave it to this virtual machine here, and now I've saved a significant amount of terabytes. But if I replace all of these databases with a virtual database, which is less than a terabyte, each one I do yields 19 terabytes of storage. I'm saving 35 hours of potential processing, provisioning time, wait time, and if I refresh all of those 6 databases, I'm actually saving masses of time, okay? And if I virtualize all of the databases, I've got a significant storage saving. And I'm moving things very, very quickly, and that storage efficiency can also reflect sustainability, not just because you've got a much smaller storage footprint, but if you're taking less than an hour instead of 35 hours to move the database, that database server doesn't have to be up for 35 hours, it only needs to be up for an hour, okay? So quite a lot of significant savings there. I've summarized it here. Massive storage reduction, massive wait time reduction, And the 100% innovation through the roof. That's not my words, that's one of our customers called Fannie Mae. And this is a great video clip that I love to show because the guy is really effusive, saying that they used to wait 3 months to get their data, now they're waiting a couple of hours, and they've got the data and they're innovating, and their DevOps is moving much more quickly. So that's how that transformation works. But the other value of having this block sharing and copy on write technology is the fact that these file pointers I can manipulate. So when I've got a virtual database, I can actually snapshot those file pointers. And if I've done some work and I understand the database, I can actually do a snapshot, which I can call a bookmark, and when I finish doing the work, I can actually rewind to those file pointers. So bring the database down, change the storage, bring it back up, and all of a sudden I've gone back to the same point in time. So this is massively valuable. It just means I've got this time travel capability, so I'm able to just rework, iterate through a process. Don't know whether you guys work on masked data, so if your data is masked, the masking process tends to break your application. So whatever iterative work that you're doing, if I bookmark first, try out some masking algorithms, and if it fails, I can rewind and go back. The other nice thing, you saw 4 of those databases. Well, actually, if I create one of these bookmarks, I've got the ability to share those file pointers. So I can restore any one of those independent virtual databases to any one of the others point in time. So I can create a bookmark and I can share that bookmark. So if you think about that, if I wanted to give any of you my data, instead of moving 10 terabytes or the compressed 3 terabytes, all I need to do is give you my set of file pointers, and you can restore your database back to a bookmark with the click of a button. So not only is that simplified things, it's given the end user, who's not a DBA perhaps, the ability to manipulate their data. The other interesting thing is I can also clone from clones. So once I've got this set of file pointers, I can create a new database from any one of the other databases. So I can clone from a clone from a clone. Now what that gives you is the ability to a hierarchy. So I can create one virtual database that's owned by the DBA team, and they can prepare that database. They might want to mask it, they might want to expire users, they might want to create new users, they might want to create some synthetic data, and then from there I can clone that out. When I refresh the masked master, that refreshes from production and I run a masking process, let's say. But when I want to refresh one of the clone databases, the downstream databases, I'm refreshing from the masked master. So I've got a separation of concerns, right? The masked master is separated from production, doesn't go anywhere near it. But the other downstream clone databases from the master are separated from it. So there's a separation of concerns. So that means I can create this one copy, and I can create multiple bookmarks on it, and then I can give various scenarios to that other team. So that kind of self-service gives me some autonomy, right? It gives me autonomy to do what I want to do. The other thing that we can use is the ability to replicate from one Delphix engine to another Delphix engine. So I've got these virtual databases, a compressed database here, and I can incrementally replicate that across to another engine. So that gives some security in that I can replicate only the masked blocks of data. So I can make that engine over there kind of PCI compliant because I've got no production data here. Here I'm connected to production, so I've got some production concerns here, but when I replicate across, I'm separating the concerns. But it also means I can keep a cloud environment in sync with production environment because I'm only replicating the changed blocks of data over to the second engine. So you get a kind of security capability, but you're also getting a resilience. So one of our customers in the US was taking their backups, standing up a system and checking that there was no nefarious or problematic activity going on that backup. They recovered their database, And they were kind of doing that manually, so it meant standing up a database and then running the application against that database. If you think about it, we can not only move the database, but when we stand up the database as a virtual database, it just takes me a couple of minutes. So a couple of values. So instead of waiting several hours to get a copy of the database and standing it up, we're waiting a couple of minutes, we get the application, and we can run the tests against that application, check to see if any of the schemas are encrypted or whatever, and then recover. So the idea is that I can have a data validation detection zone, so I can stand the database up, run some checks against that data, check that the backup is valid and restorable, and then if I find a problem, I can stand up a recovery database, solve the problem with the production database, and then we can actually take a virtual database and rehydrate it, if you like. You basically do a copy back to a physical database, and then you've recovered that. Or you can actually, we have some customers that in an emergency situation will run from a virtual database. And that's usually critical infrastructure where you can't afford the downtime, if you like. So that's how we can solve a sort of ransomware issue. What we're saying here is your database team generally has got a lot of backup and recovery. They've probably got the backups, they're probably moving them off site, and we wouldn't change any of that. You keep all of that, because really here we're not necessarily talking about production, we're talking about DevOps, DevSecOps, creating copies of data to manipulate. It may be you want to do some production offload with those databases, but that's what we're doing in that environment. But one of the key things is, you've got a copy of the database here. And it must have been about 9 years ago, we did our first user group in the UK, and we had maybe about 7 or 8 customers in the room. And one of the things I asked them was, who's used Delphix to recover a table in production? Every single one of the people put their hands up. And the reason being is it's very, very simple at the click of a button to get a copy of the database, grab a table and recover that to production. But not only that, sometimes when you get an error in production, you don't know when that error might have happened, okay? It could, you could have an error over several months and it's been dropping records. And that happened to a digital video producer in the US, and they didn't know where this problem occurred. But you can stand a database up in minutes, so you can go back in time to get to the point where the problem started, where you've got all of the data, find that table, and then forensically recover that back into production. So that's where we get with operational resilience. And that's actually the end of the discussion. But if we've got a number of customer testimonials, and it's generally all around DevSecOps, right? Automation, modernization, masking of databases. You can see these slides, you can watch these videos, and you can get a 2-minute video of how this product works. But I think the main thing is, you may have this resilience with your backup and recovery solution, but if you're running something like this to recover your databases for non-production, the fact that you're constantly testing that recovery process in setting up these databases makes it much more simple to recover a database. And if we go back to the idea of firefighter, you're recovering those databases for non-production every single day, potentially. We have a lot of customers that snapshot production on a nightly basis and are creating a copy every morning. That process transferred into recovering a production database, it means because you're doing it every day, it's very easy to do, and we've simplified it through this process so that we can automate it. So we're not saying throw away your current backup and recovery capabilities, but what we are saying, if you've got this operation that you do every day, you've got data there that you can potentially recover to. And that's it. Any questions whilst we've got some time left? Any thoughts on that? Yep. I don't know whether this is going to work. See if you can talk into that.
Hello?
Yeah, go on then.
Hello.
Touch your chin.
If it's which database this is working, is Delphix?
All right, well that's it. Yeah, that's an interesting question. It works on, I mean, essentially the file piece, we can move files on any file system, right? So the files are being moved, but we've put the work in to be able to recover the database, which is usually database type work. So that's been done on most relational databases. So it will be Oracle, SQL Server, PostgreSQL, MySQL, MongoDB, Couchbase, the list goes on. We've also done it with applications. So eBusiness Suite, we can recover both the WebLogic files, the Oracle Home and the Oracle binaries as well. Any other questions before we wrap up? Anyone just want to use a mic, sing us a song? No? Very good. Okay, thank you very much for your time, really appreciate it. Thank you.